Hello everyone, welcome back in a Scholar Hive. In the second part of this Laws of Exponent, I'm going to solve a couple of questions from level 1 as well as level 2. So this is the third lecture of this Laws of Exponent and Power series. I'll suggest that if you have not watched the first part of this Laws of Exponent, so first try to watch that video and then you can follow this second part of this Laws of Exponent. So in this video, I'll first start with quick recap of what we have learned in the first part, and then we'll go for problem solving based on those laws of exponent, and additionally we'll add one extra law of exponent, that is equality of two exponential form of number. So we have seen the laws of exponent as the product of power rule, like e to power m times e to power n is equal to e to power m plus n. And the second law, quotient law, we have seen that a to power m divided by a to power n is generally written as a to power m minus n. But if we are looking for the exponent over here, m and n, if m is greater than n, then in that case we are writing this a to power m divided by a to power n is equal to a to power m minus n for writing the exponent as a positive number. But if we have m less than n, or we can say n greater than n, then the same law can be written as a to power m divided by a to power n is equal to 1 upon n minus of n. So this was the two basics law. After that, we have seen the power of power rule, that a to power m whole raised power n, or a to power n whole power m is equal to a to the power of m into n. And also we have seen the power of zero rule, that is any number to the power 0 is equal to 1 except the base should not be 0. And also we have seen the reciprocal law, that is if we have any power as negative, then we can write it as 1 to the power of 1a to the power of n. Or if in this we have the base as a fraction, like a by b whole to the power of negative n, then we can simply get the positive power by changing the numerator and denominator. So we can write it as b by a to whole power of n. The next law that I have discussed is the power of product rule. I mean, we have any two numbers in product, a into b, and having power n, then that power will distribute among each of the base, which is equal to a power n times of b power n. And this rule is work for a finite number of multiplication of the base. Instead of just one or two, we have any numbers of multiplications of base, and we have some power. Let's say this is a1, a2, and a3. Likewise, we have n numbers, or k number is in multiplication, and we have the power n in that. So that power will goes to each and every numbers in the base which is in multiplication. So which is nothing but a1 to the power of n times a to the power of n times a3 to the power of n, and likewise it will go up to the power of ak to power n. After this, we have discussed one more law, that is the power of quotient, which is like we have any two number in division, a by b having same common power. So this power will distribute on both numerator as well as denominator. So which is equal to a to power n upon p to the power n. So these are the laws of exponent we have already covered in the part 1 of this laws of exponent. So this was the quick recap. Let's just move to the problem solving. So here's the first question, in which we have given a rational number a which is non-zero, and we have given a raised to power 7 divided by a raised to power negative 12. We need to say the value of this. So basically a to power 7 divided by a to power negative 12. So we have to just look into the options. Options, we have both negative as well as positive exponents. So just go for the simple way, common base and the power subtracted, as there is a division over here. So 7 minus of minus 12. So once we are solving this further, we will get this as minus minus as plus. So 7 plus 12, which is 19. So e to power 19, which is option number D. Now we have given this question in which the value of x is equal to 3 by 2 whole raised to power 2 times of 2 by 3 raised to power minus 4. Then we need to find the value of x to power negative 2. So first, if we see the value of x over here, which is given 3 by 2 and 2 by 3, so we can, and there is a multiplication between them, so we can make the base same by taking the reciprocal of the second number 2 by 3. So we can write this as x is equal to 3 by 2 raised to power 2 times of 2 by 3 raised to power minus 4 we have. So if we are taking reciprocal of this, then this will become 3 by 2 raised to the power, whatever be the power we just need to change the sign of that. So this is minus 4, so it will become plus 4, right? Now this is a kind of like a same base and multiplication there, so we just have to go for the like power, I mean product of power rule. So there is a common base and the power should be added over here. So 2 plus 4, which is 6. So 3 by 2 raised to the power of 6 is the value of x. But we need to find the value of x to power minus 2. So for that we can take negative 2 in the power of this equation on both sides. So by doing this, we'll get this as 3 by 2 whole power 6, and we are taking negative 2 exponent over here. So by doing this with the help of the power of power rule, we can write this as 3 by 2 to the whole power of 6 into minus of 2. So x to power minus 2 is equal to 3 to the power of 3 by 2 to the power of minus of 12. So if we look into the option, we have given 2 by 3 and 2 by 3 here. So but 2 by 3 to the raised to power minus 12, so this is not possible. We have 3 by 2 raised to power minus 12, right? But here 2 by 3 raised to power plus 12 is there, so we can get the power plus from this by using the reciprocal law. By changing the numerator and denominator over here, 2 by 3, the power sign will change, which is negative 12 here. So by doing this, we'll get it as power plus 12. So x to the power of minus 2 is equal to 2 by 3 raised to power of 12. So option number D is correct. Now this is very good questions. We have to find the value of this expression. So we can write this, we can find over here x to the power negative 2 by 3 and whole power 27 to power 1 by 3, and in denominator we have 2. So we can go for first simplifying the power of this base. So we can find that this is basically 2 by 3. Now here in the power we have 27, and we know 27 is nothing but 3 raised to power of 3. So instead of this 27 to the power 1 by 3, we can go for simplification of this. So 1 by 3, it means what? 3 to the power whole 3 and raised to power 1 by 3. So by using the power of power rule, we'll get this as 3 to the power 3 into 1 by 3. which is nothing but equals to 3. So this power becomes 3, and so we can write it as 3 by 2. Now by using the power of power rule, we can find this is nothing but 2 by 3 times of 3 by 2, right? Now power will cancel, 2 cancel, 3 cancel, so we left with 8 to power minus 1, so which is equal to, by using reciprocal law, 1 by 8, so option number B is correct. So this kind of questions, if we are getting, means make sure that this value 27 and 125, or we, as I suggested before also, it is better to remember the some powers of 2, 3 and 5, so that will save your time in finding the factorization of these all numbers, right? Or otherwise, if you're forgetting, means just go for prime factorizations, and then you will come up with the value of 27 as 3 raised to power of 3. And then by using the taking the power over here, as they have given 27 to raised to power 1 by 3, so by taking power 1 by 3 on either side of this equation, that will going to give us 3 to the power of 3 times of 1 by 3, and 3 got cancelled. We left with the value of this expression 27 to the whole power 1 by 3 as 3, and this value we just have to put over here, and using the power of power rule, we can find that these two power is going to multiply each other, as these two are reciprocal, so that is going to give us the power 1, and as there is a negative, so a to power negative 1, and by using the reciprocal law, we can find that this is equal to 1 by 8. Now let's move to the next question. This is very interesting question, so try to pause the video and solve by yourself and comment the answer in the comment box. So I'm marking this as question number 1. So if you are commenting, make sure to write the question 1 and then comment the answer for this. So here we have given x raised to power y is equal y raised to power x. Then we need to evaluate the value of x upon y whole raised to power x by y. So here we can just go for simplifying this using the laws of exponents. So x by y whole power x by y. So we can write it as like x by y whole power x times of 1 by y. Now we can write this as using the power of quotient, like x by y whole power 1 by y. This x will go in the power of both numerator and denominator. So it is nothing but x to power x and y to power x. So now we can find that in given, we have given that y to power x is equal to x to the power y. So we can plug this value over here. So by doing so, we'll get this as x to power x by, instead of y to power x, we have to write x to power of y. So this is x to the power of y and whole raised to power 1 upon y. Now we need to just use the quotient law and write, as there is a common base x and division over here. So we can write this as x to power of x minus of y whole power 1 by y. So by using the power of power rule, that is going to give us equals to x to the power of x minus y times 1 by y. So this 1 upon y is multiplied by the all x and minus y, that is going to give us x times of 1 by y minus of y times of 1 by y. Once we simplify this, we'll get it as x to the power of x by y, and this y got cancelled, so we left with minus 1. So x to the power of x by y minus 1, which is option number B. So our correct answer is option number B for this particular question. Check whether you have done the, the discussion correctly or not. Comment down if you have done this correctly. Okay. So now here this question is very good question. So let's try to solve this question and comment your answer with the question number, as this is the question number 2 for your trial. So let's start with the solution for this question, as here we can find that the expression given over here containing the first part over here 9 to the power something something, and division here and then 3 to the power something. So we can deal with this question as two parts. First we have to simplify this part and this part separately. Let me write this as part 1 and this as part 2. So the first part is, if you clearly look into this, then this is something like each base is 9, or that can be resolved into 9, because here 81 and 729, which is the power of 9 itself, right? But here this is power 3 and the power is even, so we can resolve this into the power, I mean base 9 as well. So let's start with solving this first part. So here we have given 9 to power of x times of 9 to power x minus 1 bracket close to the power x divided by 9 to power x plus 1 times 3 to power of 2x minus 2, and there is a multiplication of this 729 to the power x by 3, and in the base we have 81 and the whole power is negative x. So we can simplify this as like 9 to power x, and this power is x, so this x minus 1 is going to multiply with x, so we can directly write it as 9 times of x into x is x square, and then we have minus 1 into x is minus of x. The same way, the base is 9 to power of x plus 1, and the base is 3 to power of 2 times x minus 2, so we can write it as 3 to power 2 and x minus 1 by using the power rule. Now this 3 to power 2 is nothing but 9, so this can be simplified as 9 to power of x, and as there is a same base and multiplication, so we can add up this power, so x times of, I mean x plus x square minus x, and the base is 9 to power x plus 1, and this is 3 square, which is 9 times of x minus 1. So as this is the this part only, and this can also be simplified over here. So let me just take it to down. Okay. So this part is in multiplication, so which we can write as 729. So which is the power of 3, 9. So 729 is nothing but cube of 3. So if you go for prime factorization 7 to 9, then you can find that this is a power of 3 power of 9, right? So you can just go for like, no, like you can go for 3 as well as 9. Let's say I'm going for 3, so 3 to the 6, 4 the, and 3 3 the, again 3 8 the, 3 1 the, then next 327 times, 3 9 times, 3 3 times, and 3 1 times. So we are getting this as 3 to raise to power of 6, so which we can write it as 3 to power 2 whole power 3, so which is nothing but 3 to the power of 9, I mean 9 to the power of 3. So we can write 729 as 9 to power 3, and in that power we have x by 3, and base is 81, which is nothing but 9 power 2 whole raised to power minus of x. So again, if we are going to use the laws of exponent over here, so this is going to cancel 3 3, so we end up with 9 to power x, and using the same base like 9 to power x by 9 power 2 and whole raised to power of minus x. So further we can write this as here power x minus x cancel, and the same way we can go for additions of the power over here as well. So we can write it as 9 to power x plus 1, and here 9 is in multiplication, 9 times of x minus 1, so we can write the common base, and power will be added over here. So this is plus of x minus 1, so this minus 1 minus 1 got cancelled, and this plus x got cancelled, minus x got cancelled. So here we can get this as 9 to power x square by 9 to power of 2x, and this expression is 9 to power x minus of 2 whole power of minus x. So upon simplification, we'll get this as 9 to power of x square, and as there is a division over here, so this is minus 2x times of 9 to power x minus 2 whole power minus x, means by power law we can write it as product of this power, so minus of x square minus minus of plus 2x. Now we find that here the base is same, so we can add the power, so 9 to power of x square minus 2x plus of minus x square plus 2x. So here we can find that the x square is plus, and here minus got cancelled. This is minus, this is plus cancelled. So we end up with 9 to power 0. It means which is equal to 1. So the value of the first expression over here in the left we got as 1. We need to now simplify the value of the second expression. So let me just take it here. Okay. Now the second expression is we have given as 3 to the power a minus 2 power 3 times 3 to power a minus 2 divided by 3 power a minus 3 power a minus 1. So we need to see the expression in numerator and denominator. We can find that this 3 to power a is present in both numerator as well as denominator. So we can write this as 3 to power a taken common. So we left with over here nothing but 3 to power 0. And in the second expression, okay, if we are not getting this one, means let's just try to figure it out. Like a to the power a means we can write it as a plus 0, because 0 is additive identity, right? And this is 2 power 3 times of 3 to power a minus of 2. The same way we'll write in denominator 3 times of 3 to power a plus 0 minus 3 to power a minus 1. Now we can use the laws of exponent, power of product rules. So this is 3 to power a times of 3 to power 0 minus 2 pi power 3, and 3 to power a times of 3 to power minus 2 divided by 3 to power a times 3 to power 0 minus 3 to power a times 3 to power minus 1, right? So now we can take the power of 3 as common in numerator. We'll left with 3 power 0 minus 2 power 3 times 3 to power minus 2. And in denominator also we can take 3 power a common. We left with 3 power 0 minus of 3 to power minus 1. So we'll find that this 3 power a got cancelled. So we left with this expression. So we just have to simplify the expression over here. So upon simplification, we'll get this as 3 to power 0 means any base raised to power 0 except base 0 is 1. Any base raised to power 0 except base 0 is 1. So 3 power 0 is 1 minus of 2 to the power of 3, which is 8. And 3 to power 2 means 1 by 3 to power 2 divided by 1 minus 3 to power minus 1 is 1 by 3, right? So once we simplify this, we'll get this is equal to 1 minus 8 by 9 divided by 1 minus 1 by 3. And upon simplification of numerator, 9 minus 8 by 9, and denominator is 3 minus 1 by 3. So numerator is 1 by 9 and denominator is 2 by 3. So upon this simplification, we'll get this as 1 into 3 divided by 2 into 9. As we know, if we have a fraction whose numerator as well as denominator both are fractions, so let's say a by b in numerator and denominator c by d. So we can write this as a into d by b into c. With the same thing, we can write this as like 9 is in the denominator of numerator and 2 is the numerator of this denominator. So 2 and 9 will be in the denominator and the top and bottom will be in the numerator. So 3 ones are 3 and 3 threes are 9. So this is equal to 1 by 6. So the second part of this expression is 1 by 6 and the first part is 1. So here we have a division over here. So 1 divided by 1 by 6, it means this is equal to 1. Change this division into multiplication and the number after it we have to take reciprocal. So 6 by 1 is the reciprocal of 1 by 6, so which is equal to 6. So our answer is option number B. Now let's look into the next question. Here we have given 5 raised to power 0.25 times 125 raised to power 0.25 over 256 to the power 0.10 times 256 to raised to power 0.15. So first we need to check the numerator is having base 5 and 125, which is nothing but power 3 of 5, and in the same way we have base 256, so which is a power of 2 or a power of 4 or 16. So we just have to go and simplify both numerator and denominator. So we can write this as 5 to the power of 0.25 multiple 125 can be written as 5 to power of 3 and the whole power of 0.25 divided by 256. So 256 is 4 to the power of 4. So that can be written as 4 to the power of 4 and to whole power 0.10. If you are not remembering the values of this, then go for prime factorization. So 256 when divided by 2, that is going to give us 128 upon further division by 2, it is going to give us 64, then 32, and then 16. 2 8 times is 16, and then 2 4 times is 8, and then further 2 2 times is 4, and 2 1s are. So here we found that 2 multiplied 1 2 3 4 5 6 7 and 8 is going to give us 256. So we can write this as in terms of power 2 as well as power 4 also. So here this is 2 to the power of 8, and the same way here this is 2 to the power 8 times of 0.15. Now as the base is same and there is a multiplication, first we need to use the power of power rule over here. That is going to give us this as 5 times 5 power 0.25 times 5 to power 3 times of 0.25 is going to give us 0.75 denominator. This 2 8 times of 0.80 is going to give us 0.80, and 8 times of 15 is going to give us 1.20, because if we are multiplying 15 with 8, that is going to give us 120, and after that we have 2 digit after we have 0, so we just have to put decimal after 2 digit, so that is equal to 1.20. Now the numerator we have common base, so power will be added, so 5 raised to power 0.25 plus 0.75. The same way denominator is having common base 2 and the power is going to added as there is multiplication over there, right? So upon simplification, we'll get this as the power of 5 is 0.25 plus 0.75 is 1. So this is 5 raised to power 1, and in denominator 0.80 plus 1.2 is 2. So this is 2 to the power of 2, which is equal to 5 by 4. So the option B is the correct option. Now let's move to one of the very good question over here. So we have to find the value of this expression where x is given as 16, and in the expression we have x minus 1 over x to the power 3 by 4 plus x to power 1 by 2, and it is multiplied with x to the power 1 by 2 plus x to power 1 by 4, and then further we have x to the power 1 by 2 plus of 1, right? And then further it is multiplied by x to power 1 by 4. As x is given as 16, now in the power of x we just have to put the value of x over here. Then we'll find that x minus of 1, x minus 1 means 16 minus 1 divided by x raised to the power of 3 by 4 means 16 to the power of 3 by 4 plus 16 to the power of 1 by 2, and then same way we have 16 to the power 1 by 2 plus 16 to the power 1 by 4 divided by 16 to the power 1 by 2 plus 1, and then this is 16 to the power 1 by 4. If we are going to write 16, as we know 16 is nothing but 2 to the power of 4 by using prime factorization. 2 8s are 2 4 times and 2 2 times, again 2 1 times, right? So here we are getting 2 multiplied itself 4 times, so the 16 is 2 over power 4. So we can write instead of 16 as 2 power 4, but here this is 16 minus 1 is going to give us 15. So 15 over 2 raised to power 4 to whole power of 3 by 4 plus 2 to the power 4 raised to the power of 1 by 2. The same way over here, 2 to raised to the power 4 whole power 1 by 2 plus of 2 raised to power 4 over power 1 by 4. Same way, this is 2 raised to power 4 to the power of 1 by 2 plus 1 times of 2 to the power 4 whole power 1 by 4. Now if we see here, this is in the power, so this 4 and 3 by 4 is going to multiply it. So upon simplification of this, we are going to get this as 15 over 2 to the power of 4 times 3 by 4 plus of 2 to the power 4 times 1 by 2, right? And then here we have multiplication, so this is 2 to the power 4 times this power going to multiply, right? 1 by 2. The same way this is 2 to the power of 4 times 1 by 4 over 2 to the power 4 multiplied 1 by 2 plus of 1, and then here 2 over power 4 times 1 by 4. Now once we simplify this, we'll get this as this 4 is gonna cancel, this 2 is cancelling this by 2 times. The same way here, 2 cancelling 2 times, here 4 cancelled, here 4 cancelled, here 2 is cancelling 4 by 2 times. So we're left with then this is 15 over 2 to the power 3 plus here 2 to the power 2 into 1 is 2, and then multiply, this is 2 to the power 2 into 1 is 2 plus 2 to the power of 1 divided by 2 to the power of 2 plus 1 times of 2 to the power of 1. So once we simplify this, this is 15 and 2 to the power 4 is 8, 2 to the power 2 is 4, multiplied by 2 to the power 2 is 4 plus 2, divided by 2 to the power 2 is 4 plus 1. times of 2. Now we just have to simplify this. So this is 15 by 12 multiplied by 6 by 5 multiplied by 2. Just have to go for cancellation. This is 5 1 the 5 3 the, and this is 2 1 the 2 6 the, and this 6 1 the 6 1 the. So we end up with this value as in numerator we have 3 into 1 into 1 is 3, and denominator 1 into 1 is 1, so which is equal to 1. So the answer for this option question is option number B. Now let's move to the next law of exponent, that is the equality of the exponents. Equality of exponential form of number. Suppose we have given two exponential forms of number, let's say a to the power m and a to the power n, whose base are same, and if these two exponents are equal, then their power must be equal, means m should be equal to n. Or this is the first equality form of the exponent, and the second one is if we have two exponential form, let's say x to the power m and equals to y to the power m, whose exponents are equal, then their base should be equal. Here one thing is important. For the first case, like a raised to power m equal a to the power n, the base should not be 0. If base is 0, so for any exponent of this, like for different values of m and n, it will always be equal. For example, if I'm taking 0 to the power 5 and 0 to the power of 4, so 0 power 5 value is also 0, 0 power 5 value is also 0, as well as 4 to power 0 is also 0. Although these two values are equal, but the exponent 5 and 4, which are completely different. So this law holds true for the base except the base is 0. We can cross verify this also for the base 1 as well. So if we are taking base a is equal to 1, then in that case also if we have a to the power of 10, it means 1 to power 10, which is also giving the value as 1. And if we are taking a to power 9, which is also going to give 1 to the power of 9, which is equal to 1. So this both value of a to the power 9 and a to power 10 both are equal, but the power which is not going to come equal 9 and 10, we know that these two are not same value, right? So this law a to power m is equal to a to power n holds true except a is 0 and a is 1. We can also verify this for a negative as well. We can also verify this for a negative as well. I mean negative 1 also. Let's try to put a is equal to -1. Then we can find that for a to the even power. So a to the power of any even number will always be equal, give equal value. I mean a to power 10 or a to power 6 means a to power 10 means -1 power 10, and this is -1 power 6. Both are going to give us the value 1. So although a to power 10 and a to power 6 values are equal, but this power 10 and 6 are not going to be equal, right? So with this we can say that with this example we come up with the result that this law holds true except these three values of the base. So a to the power of m is equal to a to power n. These two exponents are equal. It means their exponent or power will be equal, except the base should not be equals to either 0 or 1 or -1. So this is very important result in the equality of exponent. Based on this, we'll discuss a couple of questions. And in this second example, as here we have taken x raised to power m is equal to y raised to power m, then the base will be equal. It means if we are going to take this any power of 0 to power of m or 1 to power m, right? So if we are taking like m is 0, means there m should not be 0, right? So if m is 0 means power is 0, means it will going to give us always this value x power m, y to power m is 0 for x and y both not equal to 0, right? So for this law we can say that x to power m is equal to y to power m. If this is the things, then we'll have base will be equal, but the condition is that the power should not be 0 and this base should not be 0. So let's try to solve the question based on this law. So here is the first question. Here I have taken few number of questions, so you try to solve the questions and write down the answers in the comment with the question number. So here this is 1a, this is 2a, and this is 3a, and this is 4a. Take question number, accordingly you can write your answer. So here in the first a question we have given the question as we need to find the value of m. We have given 25 raised to the power m divided by 5 to power minus 3 is equal to 5 raised to power 5. So this 25 can be written as 25 to power m divided by 5 to power minus 3 is equal to 5 to power 5. This 25 can be written as 5 power 2. So 5 to power 2 whole power m divided by 5 power minus 3 is equal to 5 to power of 5. So we can write this as by using power law. This is equal to 5 to power 2m divided by 5 to power minus 3 is equal 5 to power of 5. Now as the base is same and division is there, so power will be subtracted. So let's write the common base as 5 and 2m. Subtraction is there, so we need to just subtract the power minus 3 is equal to 5 to power of 5. Now this is going to give us 5 to power 2m minus minus is plus 3 is equal to 5 to power 5. Now base are same, so power should be equals. So we can write it as 2m plus 3 is equal to 5. So upon solving this linear equation, 2m is equal to 5 minus 3. So 2m is equal to 2, which means m is equal to 1. So the answer for this question is option number B. Now let's try to solve the second questions and comment your answer in the comment. So the same kind of question is there. We have given 4 by 5 to power 3 divided by 4 by 5 to power minus 3 is equal to 4 by 5 to power 3p. We need to find the value of p. So as the base is same and there's division, so we can write it as common base 4 by 5 whole power 3, and as division is there means there is subtraction and the next number power is minus 3, so minus 3 over here, which equals to 4 by 5 to the power of 3p. Now once we simplify this, we'll find that this is minus and this is also minus, so minus minus will become plus, so 3 plus 3 is nothing but 6. So 4 by 5 to power of 6 is equal to 4 by 5 power of 3p. Now here base is same, so the power will be equal, so 6 is equal to 3p. So upon division both side by 3, we'll get it as 6 divided by 3 is going to give 2, and 3 divided by 3 is 1, so this is equal to p. So 2 is equal to p, so the value of the p is 2, which is in option number C. So I will check your answer whether you have done correctly or not. So now let's try the next question and check your answer after pausing the video. First try to attempt. Okay, so now let's see how we can solve this question. Question number 3, we have to find the value of x. We have to find the value of x, and we have given 10 by 3 times 3 to the power x minus 3 to the power x minus 1 is equal to 81. So here we can find that this is 10 by 3 times of 3 power x minus 3 to the power x minus 1 is equal to 81. So 81 can be written as 3 to the power 4 by using prime factorization. So you can try it. 3 divided by, 81 divided by 3 is going to give 27. Then again divide by 3. This will give 9. 3 3s are 9. So 3 1s are 3. So this is going to give us 3 to the power 4, right? Now here we can find that 10 and 3 to the power x, and here division. So this by using the quotient rule, we can write it as simply like 3 to the power x by 3 minus of 3 to the power x minus 1 is equal to 3 to the power 4. Now this is simply 3 to the power x minus 1. So 10 times of 3 to the power of x minus 1 minus 3 to the power x minus 1 is equal to 3 to the power 4. So by taking 3 to the power x minus 1 common from these two terms, we will get it as 3 to the power x minus 1. Here 10 left out, so 10 minus here 1 left out, right? Is equal to 3 to the power 4. Let's try to solve this question number 4a. I hope you all have done correctly. So let's go through the solution for this question. So we have given x to the 8 to power x power h2 times 1 over t to the power 7 3 is equal to 0.0625 to the power x. We need to evaluate the value of x. So first try to simplify the LHS, which is x 8 to the power of x minus 2. We know 8 is nothing but 2 power 3, so we can write it as 2 power 3 whole power x minus 2 multiplied by this 1 by 2 to the power of 4 minus 3x. So if we are taking the reciprocal of this, then the sign of this number will change. So by doing so, we'll get this as negative of this number, means minus of 4 minus 3x by using reciprocal law. And this number 0.0625, we know that the 625 is nothing but 5 to power 4. So if you don't know the power of 5, just go for factorizing 6 to 5 divided by 5. 5 1s are 5, 5 2s are 10, 5 5s are 125. Then again by 5, 5 2s are, and then 5 5s are, again 5 times 5 is 25. So we'll get this value as 5 is multiplied 4 times, that is going to give us 625, right? But here we have decimal, right? So it means this is basically 2625 by 1, and after 4 digit means 4 zeros. So this is equal to this, right? So we can write this number as in terms of power of 5, or if it is possible we just have to go and simplify, and this 10,000 also we can write it as, by dividing by 2 or 5, we'll get some power of 2 and 5. So it's better that we can cancel over here, so just go for cancellation of this. we'll get this as 625. If we already know a square of 25, so when we divide it by 25, we'll left with 25, and this is 25. 4 times is 100, so we left with 400 over here. Now again, by cancelling this by 25, we'll get this as 25 on the 25, and this number as 25 on the 25, and over here we're left with 15. So this is going to give us 150, which is 6 times of 25. So on the right we left with 1 by 16 to the power of x. No need of evaluating this factorization. We can just go for simplifying this. So over here left we got it as 2 to the power of 3 times of x minus 2, and here 2 to the power of this minus, if we are multiplying with this, we'll get it as minus 4 plus of 3x, right? On the right we left with 1 by 16 whole power x. So now just we have to simplify the LHS as the base is same, so power will be added. So 2 over power is 3 times of x, and minus here is 3 to the 6, and then we need to just add this value 3x minus of 4. On the right this is 1 by 16. 16 is 2 over power 4, whole power is x. So now on the left we left with like here 2 to the power of 3x plus 3x is 6x, 2 to the power 6x minus 6 minus 4 is minus 10 is equals to, by using reciprocal law we can write it as 2 to the power of minus 4 whole power x, because like 1 by a to the power n is equal to a to the power of minus n. But this reciprocal law we can write this as 2 to the power minus 4. So basically the power of power law will give us minus 4 into x is 4x, and left side 2 to the power of 6x minus of 10. Now here base is same, so power will be equal, so 6x minus 10 is equal to minus 4x. We need to solve this for x. So 6x, by substituting, by transposing this 10 to right and minus 4 to left, we'll get it as plus 4x, and this is equal to 10. So this is 10x is equal to 10, which implies that x is equal to 1. So the answer for this question is option number D. Option number D. Now let's try to solve this fifth A question. Okay, so the next question is to find the solution of this exponential equation. So this is exponential equations and in terms of the variable x, so we just have to solve this by using the equalities of exponents. So no need of doing anything in the LHS, just keep it as it is, 3 raised to power 3x minus 5. On the right, by using reciprocal law, we can write it as 1 by 9 as 9 to the power of minus x. Now 9 can be written as 3 power 2, so this is 3 power 2 whole power minus x, and in the left we have 3x minus of 5. So we can write this as 3 to power 2 into minus x is minus 2x, and left is 3 to power 3x minus 5. Now as the base are equal, so we can write the power equals, and then we need to just solve for the variable. So by using transpositions, we can transpose 2x negative to left and 5 to right. We'll get it as 3x plus 2x is equal to 5. So here it is 5x is equal to 5, means x is equal to 1. So the answer for this question is option number C. Now these two questions are very good questions based on the like the law we have discussed just now. We need to find the value of 3a plus 4b when this exponential equation is given, as well as the second questions. So first try to solve this question 6a and then go for 7b. Okay, so we need to find the value of 3a plus 4b. We have given 64 to the power a is equal to 1 by 256 to the power of b. So here, the 64 can be written as 2 to the power of 6 by using prime factorization. So go for prime factorization of 64. Dividing this by 2, that will give us 32. Again dividing it by 2, that is going to give us 16. 2 divide 16 is 8, 2 divide 8 is 4, and then this is 2 and 1. So this is like 2 multiplied 6 times, so this 64 is nothing but 2 over power 6 to whole power of 8 is equal to 1 by 256. 256 also can be factorized and we'll get this value as 2 to the power of 8. So just go for it. 2 divide 256 is 128, 64, then 32, then 16, 8, 4, 2. So which is 2 ones are. So basically here we can find that 2 is going to multiply 8 times, that is going to give us 256. So this means 256 can be written as 2 over power of 8 power b. So this 2 over power 6 into a using power rule. So because a, this is using this law, a to power m over power n is equal to a to power mn. So with this law we can write both of this LHS and RHS. So RHS is 1 by 2 to power of 8 into b is 8b. Now we just have to use the reciprocal law to write this 1 by 8 to power b in terms of negative exponent. So over here, this is equal to 2 to the power of minus 8b is equal to 2 to the power of 6a. Now the base are equal, it means the power will be equal. So 6a is equal to minus 8b. So once we solve this, as we can find that both of this side we have 2 is common. So by cancelling both sides by dividing both sides by 2, we end up with 3a is equal to minus 4b. So if we are bringing this to the left, we'll get it as 3a plus 4b is equal to 0, which is the value of the given expression that asked in the question. So option number D is correct. Now let's try to solve the second part of this question. I mean 7b question. We have given 3 power x plus y is equal to 81. So it means 3 power x plus y, as 81 is nothing but 3 to power of 4. So this is 3 to power of 4, which implies the base are equal, means x plus y will be equal to 4. Now with the second equation, 81 to the power of x minus of y is equal to 3. Again we write this 81 as 3 to power of 4 whole power x minus y is equal to 3. So by using power of power law, this 4 will be multiplied by x minus y. So this is 3 to power of 4 times of x minus y is equal to 3. Now the base is same here, power of 3 is 1. So this 4 times of x minus y will be equal to 1. So this is the second equation we got over here. 4 times of x minus y is equal to 1, and the first equation was x plus y is equal to 4. So with the help of these two equation in two variable, we can further simplify this as 4 times of x minus 4 times of y is equal to 1. So these two equation we have to solve for x and y. So for that we need to just solve any one equation from first equation, this equation, we have to find the value of x or y, and that value of x and y we need to put in this, and further we need to solve this for y. So let's say I'm evaluating that in this equation, y is equal to, as x is in plus, 50 to the right, that will goes into minus, so y value is equal to 4 minus x. So this value of y we need to put this in this second equation. So this is 4x minus 4 times of, in place of y we need to write 4 minus of x, 4 minus x, which is equal to 1. So just expand it, 4x minus 4 into 4 is minus 16, and this minus minus plus 4, x is equal to 1. So 8x minus 16 goes to the right, that is going to in plus, so 1 plus 16. So 8x is equal to 17, it means x is equal to 17 over 8. This is the value of x. So to find the value of y, we just have to plug this value of x that we got over here in this equation. So that is going to give us y is equal to 4 minus of 17 by 8. So upon simplification of this is 8 4s are 32 minus 17, which is going to give us 15 upon 8. So the value of y is 15 over 8, and the value of x is 17 over 8. So in this question they are asking the value of x and y. So the value of y is this, the value of y is, okay, this one, and the value of x is 17 over 8, value of y is 15 over 8. Now let's try to solve some more questions on this. We have given the equality of two exponential forms of the number. We need to solve the value of m. So first we need to just simplify the LHS, as we can find that the base over here is 2 by 9, and on the right also base is 2 by 9. So using the power 2 by 9 as the common base, and the power will be added. 3 plus minus 6 is equal to 2 by 9, power of 2m minus 1. So as the base are equal, so the power will be equal. So 3 plus 3 plus minus 6 is equal to 2m minus of 1. So upon simplification, this is 3 plus minus 6 is minus 6 is equal to 2m minus 1, which is minus 3 is equal to 2m minus 1. So if we are solving this, minus 3 plus 1 is equal to 2m. By position, if we are shifting to this left side, this sign will become plus. So this is equal to minus 2 is equal to 2m. It means m is equal to minus 2 by 2, which is equals to minus of 1. So the answer for this question is m is equal to minus 1. Now, based on the same concept discussion, we need to find the value of n. We have given 4 to the power of n minus 9 is equal to 256. So 4 is nothing but 2 power 2 whole power of n minus 9, and 256 is 2 power 8. By using prime factorization, we can find this as 2 over 8. Now using power law, we can write it as 2 to the power of 2 times of n minus of 9 is equal to 2 power 8, as the base are same, means power will be equal, means 2 times of n minus of 9 is equal to 8. We need to solve this for n. This 2 is in multiplication, move to that side, or we can go for cancellation. 2 ones are 2, 4 by 8. So here n minus 9 is equal to 4. So n is equal to 4 plus 9, which is equal to 13. So the value of n is 13. So I said before also, it is good to remember some of the values of the two power, which is like from power 1 to power 10 values. It will save our time for evaluating the prime factorization. So this 2 power 8, how I evaluated by using the prime factorization. 256 divided by 2, 128 divided by 2 is going to give us 64, divided by 2 is 32, and this is 16, and again this is 8, and then divide by 2 is going to give us 4, then 2 twos are, and 2 ones are. Here if we are counting this, the 2 over here is how many times 2 came? 1, 2, 3, 4, 5, 6, 7, and 8. That's why this is 2 to the power 8. Now this is a very good question. We need to find the value of m, least positive integral value. Here least means small and we need to look for positive, but integral value means integer value. You have to find the value of m which should be integer, not a decimal, not a fraction. So first, to find the value of m, we have to simplify the expression inside this curly bracket, which is 1 by 3 whole power minus 1, so that we can write it as by using reciprocal law. 1 by 3 whole power minus 1 is nothing but 3 to the power of 1 by using reciprocal law, as well as 1 by 4 whole power minus 1 is written as 2 to the power 1. So this expression will become 3 minus of 4 whole power of m is equal to 1. So here 3 minus 4 is minus 1 to power of m is equal to 1. We have seen that if the power of negative 1 is even, then only it will give us the positive value, and if it is odd, then it will give us the negative value. Here is in discussion they ask the positive as well as least value of m, and that should be integer. So here positive, as we know 0 is neither positive nor negative, so it is not possible. And if we are taking 1, then negative 1 to the power 1, which is odd, which is going to give us minus 1, so this is also not possible. So the next value of m that we can check is m is equal to 2, which is positive. So here minus 1 to power 2, which is even, so that is going to give us the value as plus 1. So the least value of m, which is going to give the like solution for this equation, is nothing but m is equal to 2. M is equal to 2 is the correct answer for this particular question. Now let's try to solve this question. We have given 2 over power x minus 1 plus 2 to the power x plus 1 is equal to 320. We need to find the value of x. So here we can just write with the using the power of product of power rule. 2 to the power x minus 1 can be written as 2 power x times of 2 power minus 1, plus same way here this is 2 power x times of 2 power 1 is equal to 320. Now 2 to the power x, if we are taking common, we left with 2 power minus 1 plus 2 power 1, which is equal to 320. Now we just have to simplify this. 2 power minus 1 means 1 by 2 plus of 2 is equal to 320. So now upon simplification of 1 by 2 plus 2, which is nothing but 5 by 2. So this is nothing but 2 power x, 1 plus 4 by 2 is equal to 320. So this is 2 power x times of 5 by 2 is equal to 320. So also we can just go for simplification of this as well. So we can further simplify this by, if we are just writing this as 2 power x times of this multiplied by 5 is equal to 320. Now here we can go for further simplification of this as well, or we just have to cancel this 0 by multiplying and dividing both numerator as well as denominator. By doing this, we'll get this number as 10, and this 10 will cancel this 0 over here. So we can find that we have 2 power x by denominator is 2 to the 4, hence 2 to the power 2, and here this is 5 to the 10 is equal to 320. So this 0 got cancelled. We end up with 2 power x is equal to 32, which is nothing but 2 to the power of 5, and this denominator is 2 power 2. So if we are going for cross multiplication, so we end up with this 2 power x is equal to 2 power 5 times of 2 power 2, which is going to give us 2 power x is equal to base is same and multiplication is here, so we can add the power over here. So 2 power x is equal to 2 power of 7, base is same, means x is equal to 7. So the answer for this question is, the value of x is 7. So let's try to solve this question and comment the answer for this. This is 8A. With the question number, you write the answer in the comment box. So here we have given in base a by b power x minus 10, and on right we have given b by a over power x minus 16. We need to find the value of x. So by using the reciprocal law on right side, we can make the base of both left and right equal, same. As in left we have given a by b, on right we have given b by a. If we are using the reciprocal law, means if we are interchanging numerator and denominator, then the exponent sign will be changed. As here we have x minus 16, so it will become negative of x minus 16. And on the right we have left we have a by b to whole power x minus of 10. Now we have base same, it means power will be equal. It means x minus 10 is equal negative x minus of 16. We just have to solve this equation for x. So here in left, x minus 10 is equal to negative x there. So this negative will be multiplied with this first term as well as the second term. So negative x, and here positive. So negative positive is negative x, and this negative is positive 16. So now transposing this x to the left and this minus 10 to right, we'll get it as x minus goes to left as plus x, and equal to 16 minus 10 goes to right as plus 10. So this is 2x is equal to 26. It means upon dividing both sides by 2, we'll get it as x is equal to 13. So the answer for this question is x is equal to 13. Okay, so these are the question that we have discussed based on the equality of exponents. Now in this exponents and power series, this was the third lecture. So two more lecture I'll make in this series. The next will be based on the some more questions based on these all laws of exponent that we have discussed, and then scientific notations, a standard form of a number, how we can express the very big number and very small number. And also one more video I'll make for the basics of the radicals, how we are dealing with the exponents if that is in fractions. So some laws on the radicals also will cover in the last part of this video. So try to like go through the questions, try to attempt by yourself, and if there is anything which is not clear in this video, so you can comment down and you can suggest me the more kind of topic which I need to make after the completion of this exponents and law. So hope you all understood the concept, and the kind of questions I have taken is from easy to moderate to and some good level of questions. Okay, so stay tuned and just try to active on the channel and follow the channel as well as share it with your friends too. We'll meet soon in the next part of this Laws of Exponent.